In 1610, when Galileo first pointed his telescope at Saturn, he was absolutely stunned. What he saw made no sense. Saturn appeared to have two giant ears sticking out from the sides. What the hell is this thing? He must have thought. Eventually, he figured they might be two massive moons flanking Saturn like cosmic bodyguards. 2 years later, Galileo looked again, and the ears were gone. Saturn was just a normal planet. He genuinely couldn't tell if he was going crazy, if his eyes were failing, or if his memory was just playing tricks on him. Another 2 years pass, and Galileo checks a third time. The Guardians are back. Completely baffled, Galileo concluded that Saturn must have grown some kind of mysterious arms, and he even suspected these might be smaller planets that Saturn had eaten. Now, hundreds of years later, even a kid could tell you what those appendages really were: Saturn's rings. Christian Huygens confirmed this 50 years after Galileo. And while planetary rings aren't exactly rare, all 4 gas giants in our solar system have them. Nothing comes close to Saturn's rings. They're absolutely majestic and ridiculously complex, with all their different colors and structures from inner to outer edge. Scientists still can't agree on exactly how many distinct rings there are. So why did Galileo miss them that one time? Simple. Saturn's rings have one defining feature: they're insanely thin. Saturn takes 30 years to orbit the Sun, and every 15 years, the rings align edge-on with Earth. When that happens, we're looking at the absolute thinnest profile of the rings. For Galileo, they basically turned invisible. Fun fact: the next time Saturn's rings will disappear is March 2025. So ring fans, mark your calendars. The second major thing about Saturn's rings: they're bright. Like, really bright. This makes Saturn's brightness fluctuate dramatically depending on our viewing angle. When we see maximum ring surface, Saturn appears about 50% brighter than when the rings are edge-on. So here's the big question. Why are Saturn's rings so bright? How did Saturn end up with such insanely complex ring structures? And why does Saturn have 146 moons, crushing even Jupiter's measly 95? Scientists recently discovered something wild. All of this might be the result of one massive catastrophic event. When I say recent, I mean cosmically recent. We're talking the age of the dinosaurs. In this video, we're going to unpack this mysterious event step by step, and I promise you'll actually understand it. Scientists can't count every single ring. There are just too many. But they've organized them into 7 main sections: A, B, C, D, E, F, and G. They're named in order of discovery. The main rings, A, B, C, and D, were found first, and you can clearly see they get darker as you move inward. Why? It's actually pretty straightforward. These rings are what's left when stuff gets too close to Saturn and crosses the Roche limit, where Saturn's gravity literally tears objects apart. So the closer you get to Saturn, the more brutal the gravitational force is, and the more finely everything gets shredded. The outer A and B rings still have plenty of pebble-sized chunks floating around. By the time you reach the C ring, everything's been ground down to fine sand. And the innermost D ring, you can barely see it because it's just micron-scale dust. We're talking 0.001 millimeters here. Saturn's basically operating as a precision grinding machine. When light hits these rings, bigger particles reflect better. So naturally, the chunky outer rings look brighter than the powdered inner ones. It's actually the opposite of cities, where the center is usually the brightest. Now let's talk about how absurdly thin these rings are. The A, B, and C rings stretch 300,000 kilometers across. You could line up 20+ Earths side by side. Light takes a full second to cross that distance, but according to spacecraft data, they're only about 100 meters thick. The brightest part, the A ring, just 10 to 30 meters thick. I know some of you have seen Saturn photos online and thought, oh, the rings are paper thin. Honestly, you're not wrong. Here's the mind-blowing comparison. If Saturn's rings were scaled down to the size of a sheet of paper, they'd be 1/100th the thickness of that paper. You could literally crumble them between your fingers. And here's the thing, when you actually get close to Saturn's rings, they're not smooth at all. They look smooth from far away, but up close, it's just a massive collection of ice chunks and dust. The surface isn't even uniform. Scientists have photographed dust mountains along the outer edge of the B ring that rise over 2,000 meters high. Now remember, there are huge gaps between the different ring sections, A, B, C, and D. So why do these dust mountains form at the edges of gaps? Are they like cosmic walls built by gods to keep space zombies from crawling out? Nope. The truth is way cooler. Saturn's moons actually live in these gaps. Their gravity hoovers up all the dust in their orbital path, creating these chasms. The dust that hasn't been sucked in yet, that piles up into mountains on the sides. Take the Encke gap in the A ring. That big, obvious gap is basically the private estate of Pan, also known as Saturn Vecteenth. And Pan is, well, let's just say it's not winning any beauty contests. Looks like a spinning top? Why name a spinning top Pan? Well, if you know anything about Greek mythology or astrology, Pan is the god that inspired the Capricorn constellation. Goat head, extremely horny, full-time shepherd. Scientists thought this moon, which uses its gravity to keep dust in line, was basically hurting particles. So Pan the shepherd makes sense. But here's the thing. Pan isn't actually a shepherd moon. It's basically guilty of false advertising. Because scientists soon found moons that are way better shepherds. Check out the super narrow F gap on the outer edge of the A ring. That gap exists because of two moons sitting on either side, Pandora and Prometheus. They're like two sheepdogs herding the F ring, keeping ice and dust from wandering off. You can literally see the waves Prometheus's gravity creates in the F ring. Scientists call this gravitational herding. These two are the real shepherd moons, also called shepherd satellites. Fun fact, you know that moon Pandora in the movie Avatar? The one that's a moon of a gas giant. Yeah, that was inspired by Saturn. By the way, two of Saturn's moons are suspected to harbor life, but we'll dive deep into that in future videos. Now, Prometheus, the other shepherd moon, comes from Greek mythology. His brother Epimetheus is also a Saturn moon. Saturn has so many moons that scientists literally had to raid mythology for names. Quick mythology refresher. Prometheus stole fire and gave it to humanity. Boom, civilization. Then Pandora married his brother Epimetheus and opened her box, screwing over humanity. Classic Greek drama. Here's where it gets wild. Prometheus has the weirdest orbital characteristic in the entire solar system. It's a co-orbital satellite. It shares the exact same orbit with another moon, Janus Saturn X. Scientists first discovered Janus and were totally confused because its mass seemed to keep changing. Turns out there were two moons. These two guys trace out a horseshoe-shaped path, and every 4 years they swap orbits. Don't worry, they won't crash. Looks sketchy, but they've been pulling off this cosmic dance for hundreds of millions of years. Okay, I realize these topics can easily spiral into tangents. There's just so much cool stuff to cover. Let's get back to the rings. Earlier I mentioned the Encke gap inside the A ring. But the biggest gap, the Cassini division that separates the A and B rings, has no moons in it at all. Why? This brings us to orbital resonance, which I covered in my Jupiter videos. When two celestial bodies have similar orbits, they can lock into resonance with each other. What's really interesting is that Saturn's moons can also resonate with the rings themselves. Janus, for example, creates these circular stripe patterns up close, and spiral patterns from far away in the B ring. The more distant moon Mimas constantly pulls dust outward, carving out the massive Cassini division, while also locking into a 2W1 resonance with the A ring. Translation: the dust goes around twice for every time Mimas goes around once. Mimas is so powerful it simultaneously resonates with gaps in the B and C rings, and with Pandora. These complex multi-body interactions create Saturn's incredibly intricate ring structure. Now, here's where energy conservation comes in. Orbital resonance burns energy. You can probably guess that. This energy dissipation gave Saturn what might be the solar system's best candidate for alien life, Enceladus, Saturn II. This gleaming ice world creates the E-ring, and its unstable crust constantly cracks open and erupts like volcanoes. Except instead of lava, it spews ice and snow. The cryovolcanoes at its south pole shoot 200 kilograms of ice crystals per second into space, ultimately forming the E-ring. What powers this ice-spewing extravaganza? After investigating, scientists found its orbital resonance between Enceladus and another moon called Dione. Great. Another impossible-to-remember name. Honestly, if we were Saturnians, we'd have to memorize the names and features of 100-plus moons for college entrance exams. That would be brutal. Thank God we're Earthlings. How many moons do we have? The moon. Just one. Easy. Anyway, the energy from orbital resonance heats up Enceladus's interior, creating cryovolcanoes. So we've got ice and heat. But is there an ocean? Yes, a 2015 study confirmed Enceladus has a global ocean under its surface, with hydrothermal vents at the bottom. Plus, the ice shell above isn't completely sealed. There are cracks everywhere. So what does a stable, warm ocean with no harsh environmental conditions mean? It means there's a damn good chance life exists there. Saturn's got another one. Its name is super easy to remember because it's the biggest Titan, Saturn Z. Titan is the only moon in the entire solar system with a substantial atmosphere, and 98% of it is nitrogen. Catch that. Earth's atmosphere is 78% nitrogen. Titan and Earth are the only two bodies in the solar system with nitrogen-dominated atmospheres. The catch: Titan is freezing cold, minus 179.5 degrees Celsius. Scientists have even found massive lakes filled with liquid methane on its surface. So if there's life on Titan, definitely wouldn't be Earth-like life like on Enceladus. It would be a completely new form of life, maybe using liquid methane as a solvent instead of water. Saturn's moons are genuinely bizarre and endlessly fascinating. But we're running out of time, so let me quickly hit 3 more weird ones. Rhea, Saturn V. It's a moon with its own ring system. A moon with rings. Iapetus, Saturn E8. One hemisphere is dark as blood, the other is snow white. In video game terms, this is basically a light-dark dual-element character, absolutely top tier. Also has this insanely long ridge running along its equator, reaching 20,000 meters high. Scientists have no idea how it formed. It looks evil. Hyperion, Saturn 7. Looks like a sponge or coral, covered in craters and cavities. This is literally a moon you could enter from one side and exit from the other. Alright, let's circle back to the big question. Why does Saturn have 146 moons and thousands of rings? What the hell happened? Scientists have been scratching their heads over this for a while. Logically, Jupiter, with 3 times Saturn's mass and the title of solar system heavyweight champion, should have the most moons. Honestly, this would have been true just months ago. The battle for moon supremacy between Saturn and Jupiter has been going back and forth for years. In 2019, Saturn discovered 20 new moons, hitting 83 and overtaking Jupiter's 79. But this past February, Jupiter struck back, 92 moons, reclaiming the throne. Then immediately in May, scientists discovered 60-plus new Saturn moons, bringing the total to 145. Saturn didn't just take back the crown, it obliterated the competition. Current score, 146 to 95. Jupiter fans, it's over. But here's the kicker. This latest discovery revealed something crucial. These new moons are mostly irregular outer satellites. They look like fragments of something big that got smashed and now just tumbles around chaotically. That's evidence number 1. Now consider the rings. 98% ice. Recent research shows this ice melts in sunlight and falls to Saturn as ice rain. Do the math. And in about 100 million years, the rings will be completely gone. By the same logic, the rings can't be that old either, probably only around 100 million years old. Combine these 2 pieces of evidence, and scientists suspect something massive. Not long ago, Saturn's moons had a catastrophic collision. Maybe an icy moon like Mimas wandered into the Roche limit and got completely shredded, forming today's spectacular ring system. Think about it. Saturn's rings look vast, majestic, almost divine. Humans see them and assume they're eternal, unchanging cosmic monuments. Compared to them, Earth's mountains and rivers seem insignificant. But from a cosmic perspective, Saturn's rings are incredibly temporary, just a beautiful accident. Since the solar system formed, Saturn has seen countless wonders come and go. She's witnessed so much, experienced so much. Most of her life, she's been just like the other gas giants, completely ordinary. Until yesterday, cosmically speaking, when this beautiful accident happened to embrace her. For Saturn, it's not a big deal. She doesn't need to stop for it, because as a planet like Earth, she spends most of her life orbiting her star like a faithful shepherd dog. Their purpose is to sweep up the dust around stars, to grow larger, stronger, to extinguish the fire within, and eventually to die. Humanity is also children of the stars. And the universe, it's nothing more than a dance.